Welcome to the last two problems for the day 2 sine and cosine lesson. So with example 4, we're looking at a graph and we're being asked to write the graph as a trig function. I'm going to choose to focus on this part of the graph, the part that starts with 0 and ends at pi over 3. So don't let all those red dots fool you. Those are not our tick marks. Our tick marks are going to be included within this one period of what appears to be a sine graph. That's the first thing that we notice if our graph starts when we're looking at the origin. If the y value of the graph is also 0, we know that it's a sine graph. That's one thing that we can tell. We're also aware that our graph is made up of, 5 important points. We can put those points in there. And we know that there are 5 tick marks. 2 of them we don't have written down, but that's okay. We don't need to know the tick marks right now. So we know we're dealing with the sine graph. What else can we tell by looking at it? Well, we can tell the amplitude, right? Because we know the amplitude can be found by looking at the midline and seeing how high the highest point is, and it's up 1/2. A reminder, the amplitude is always positive because it's measuring the distance from the midline to the highest point, or the midline to the lowest point. That's going to be the same answer. And so we also want to see if there's any reflecting going on over the x-axis. And so we notice that the pattern is staying true, right? 0, well, it's not going to be really 1, so it's middle, up, middle, down, middle. So we know that there's no negative in front of the amplitude. What else do we notice? We notice that we complete a full cycle of the pattern. We complete a period from 0 to pi over 3. So we know that one period is completed every pi over 3. Is there a horizontal shift? Do we start anywhere differently than 0? Nope. So there's no horizontal shift. Is there a vertical shift? Was our midline changed from 0? Nope. So there's no vertical shift. And we pretty much have covered everything. Now let's take what we've written down and put it together to come up with the equation of this mystery graph. All right, so we know it's sine. We're going to start there. We've got y equals. We're going to put a sign. We're going to leave a space for the amplitude. We know the amplitude goes in front of sine, so we're going to pull that 1/2 down. And then if our period were a regular old 2 pi, we would just put theta after sine, right? But we know because our period's different than 2 pi, there's a mystery value in front of theta that changed the period. So how are we going to find this mystery value? Well, first we're going to remind ourselves, let's pick up, I don't know, okay, orange, that sounds good. We're going to remind ourselves that we get the period by taking 2 pi and dividing by the number, whatever number is in front of theta. So that's how we know that there's a mystery value there, because if there was just no number there, like the number 1, then our period would be 2 pi. But our period's not 2 pi. So our period is pi over 3. So if our period is pi over 3, and we know that we get our period by taking 2 pi divided by whatever number is in front of theta, we can set up a proportion and solve and find out what goes in our mystery box. So here we go. Let's go ahead and cross multiply. Pi times box is pi box. Yes, we could be using x. I don't know why I like a box. It just makes sense for me to do it this way. And then we cross multiply. 3 times 2 pi is 6 pi. And then to solve for the mystery box, we divide both sides by pi. Kind of brings me back to, I don't know what grade, 4th, 5th grade, right? Instead of x's, we use boxes. Those were the good old days, right? So we know that our mystery number is 6, which makes sense once we know it, right? Because of course, to find our period, we take 2 pi, we would divide it by 6, and what would we get once we simplified it? Pi over 3, which is our period. So this is our mystery equation. Or not our mystery equation, it's our equation to the mystery graph. All right, let's do this last one. Let's look at this. I'm going to go ahead. Once again, I always try to start so I don't have to deal with a horizontal shift. Just keeps things easy. I look at the origin, and if I've got a nice solid point there, I'm going to use it. So I'm going to look for 5 points. I should be seeing in this case, down, middle, up, middle, down. So I'm looking for my 5 points, my midline. It's kind of hard to tell. Probably right about here. Nope. There's my middle. Then I'm going to say that's a 6. If you don't have a 6 there, go ahead and put that. Then we've got back down to 4 and then back down to 2. And I see that I have my 5 points, right? My 5 tick marks are 0, 1, 2, 3, 4, and 5. And that completes, I'm sorry, not 5. I would have way too many tick marks. I only need 4 tick marks, right? 0 counts as one of them, so I have 5 tick marks. And I notice that I have this pattern of down, middle, up, middle, down. I'm not starting in the middle, so it can kind of get confusing. What's going to help here is actually drawing a midline. So let's stop for a second and draw our new midline. And then it makes it easier to see we're not dealing with sine. Sine always starts on the midline, which is our, in our standard form, our parent function of sine, it always starts at 0. But if you think about it, it always starts middle, then it goes up, middle, down, middle. So we're not dealing with sine, right? We could be if we wanted to shift it over 1, but I'm not going to do that. You can if you want to and show off. So here we go. So we know that we're dealing with cosine, so I'm going to write that. I've got cosine. I'm going to start at 0, so there's no horizontal shift. Now, is there a vertical shift? Our midline changed, so that means I have a vertical shift. So my vertical shift got moved up. Instead of the midline being at 0, it's now 4. So my vertical shift is a 4. Let's see what else that we notice. We're going to be able to see the period, right? If I start at 0 and I end at 4, that distance is 4. So I know my period is 4. So once again, we're looking at our graph. We're just writing down anything we see so that we can write the equation of the line from it. There's something else that I see that's involved here. Cosine always, the normal cosine pattern is 1, 0, negative 1, 0, 1. That's the parent function. But we know that cosine is always up, middle, down, middle, up. And so what we're looking here is the opposite of that, right? We're looking at down, middle, up, middle, down, which tells you that it's been reflected. So we know that since it's been reflected over its midline, we know that there's going to be a negative involved in front of our amplitude, which let's stop and talk about our amplitude. How far up is the highest point from our midline? Well, 6 is 2 away from 4, so our amplitude is 2. And we're going to remind ourselves to put that negative in front of the 2 to show that we see that the graph is reflected over its midline. All right, let's put it all together. I know we've got y equals. Now, there's a lot of things that we have to take care of. I personally like to take care of the vertical shift first. Okay, it's going up 4. I'm going to put the 4 here. Now, I'm going to write it 2 different ways, and then you can choose however you want. A lot of people like to put the plus 4 at the very end. I like to put it in the beginning, but I'm going to do it both ways. Then what comes next is if you have a reflection, which we do, the minus sign comes here, and then the amplitude comes after. So let's rewrite it both ways. We know that we have cosine, right? So we're going to write cosine there. Cosine here. Once again, I'm showing you, it's probably confusing, so sorry about that. I'm showing you 2 different ways to answer this, either this way or this way. And we're not done yet, are we? We know we would be done if our period was a regular old 2 pi. If our period was 2 pi, we just put a theta after a cosine and be done with it. But it's not. So we have to remind ourselves, switch up. We have to remind ourselves how we get our period. Our period is always found by taking 2 pi divided by whatever number is in front of theta. Now, we know that we have a theta here, right? We have a theta here, but we don't know what's in front of the box or what's in front of the theta, what's in the box. Okay, once again, I'm writing the equation 2 different ways. Probably confusing. Bad idea, Miss Overby, but I'm just going to keep going. So what is in front of the box? I'm sorry, what's in front of the theta that's making this period different than 2 pi? Well, let's find out. We know that our period is 4, right? We can see that from our graph. So we know the period's 4. And we also know we get the period by saying 2 pi divided by whatever's in front of theta. I'm going to put 4 over 1 so I can have a nice little proportion to solve. I'm going to cross multiply. 4 times the box is 4 box. 1 times 2 pi is 2 pi. And divide both sides by 4 and simplify, and I get the box is equal to pi over 2. So that's what I'm going to write in the box. I'll come back over here, take rid of the box. Oh, okay. Let's just pick up the black marker and see what we can write. All right, so we have 2 cosine. The pi over 2 goes in front of theta, and that takes care of that. If we're going to write it this way, we have pi over 2 over theta, but look what we're going to have to do. If we don't include parentheses here, you're going to get this wrong, because if you're going to write the equation this way, your plus 4, your horizontal shift, your vertical shift has to be separate from your angle because they're not the same thing, right? All right, so that's that. I think these are fun. Hopefully you're going to have fun doing your practice, and thanks for joining me.